This is Reigate College Year 2 Pure 6 Maths, and we're going to cover the first section on numerical methods, which is locating roots. So numerical methods is all about methods where we can't be precise about what we want to do, and often something we want to do with a function or an equation is to find its roots. So we're just going to consider now a way of finding where a root is, and then we'll look at how we can narrow down and make it more exact. So what we're going to consider is we're going to consider two functions, f of x and g of x, and we're going to say that they're continuous. That means that they don't have any breaks in them. We'll just have a look at that, what that really means in a moment. And I'm going to say for two values of x, a and b, f of a is less than 0 and f of b is greater than 0. So if we put that, f of a is somewhere down here, so that's the y value f of a, and f of b I said was greater than 0, so it's going to be somewhere up here. F of b is up there, and what that means is that somewhere in between the function f, between a and b, the function f must cross the x-axis. So we don't know exactly what it does in the meantime, but it does something like that. So at this point here, f of x is equal to 0, and that's our root. So we can now say that f of x has a root between a and b. So f of x has a root alpha, and alpha is less than b and it's greater than a, is often the way it's written. We've got actually the same situation with g as well. I've used the same a and b, so just to show you that it doesn't have to be going from negative to positive, could be going from positive to negative. So if we said that g of a is up here, g of a is positive, there it is, and g of b is negative, is less than 0, so let's put it down here, g of b, that's going to be there. So then we've got the same thing. I can draw down here, and here's our g of x equals 0 at this point. So we also have g of x has a root, let's call it beta this time, beta, and beta is also between a and b. Okay, we don't know exactly where they are, they could be anywhere between here. Now, just to show you why that continuous is really important, let's just consider the function h of x, which I've said is equal to 1 over x minus 2. We consider substituting 1 in there. H of 1 is going to be minus 1, it's 1 over minus 1. So here's minus 1 here, here's our 0.1 minus 1. And h of 3 is equal to 1, so if we make that out there, we've got a point there, so that's 1, that's 3, that's 1. But we know how to sketch reciprocal graphs, don't we? And reciprocal graphs have asymptotes, and here the asymptote is at x equals 2. So if we sketch that in, here's our asymptote at x equals 2. And our graph of h of x is going to look something like this. The x-axis is also an asymptote. So there's that section of it, and this section of it is going to look something like this. It's going to go like that. X-axis also an asymptote. So why is there no root between 1 and 2? Well, there is no root between 1 and between 1 and 3. There's no root between 1 and 3 because h of x is not continuous in that range of values because there's an asymptote in between. Now, usually we can deal with functions which are continuous, so any polynomial function, so that's just powers of x, positive whole number powers of x, is going to be continuous. We also know lots of other continuous functions, for example trig functions, sine and cosine, not tangent of course. So often that's not going to be a problem. So let's have a look at how, when we've got a question question like you might guess in the exam, what you're going to have to do for this. So this question says the curve with this equation intersects the x-axis at the point where x is equal to alpha. Show that alpha lies between -1 and -2. What we're going to do here is we are going to substitute in. So we're going to say, actually, let's define our function. So let's say let f of x equal x to the power of 4 plus 2x cubed plus 8x plus 15. And then we've got to show that its root lies between these two values. So we're going to substitute in -1 and substitute in -2 and see what we get. So if we do that, we get f of -1 is equal to, and then you can put this into your calculator. I've already done that. We get a value of 6. If we put in -2, f of -2, you've got to do this carefully, of course, we get a value of -1. Okay. And then what we're going to do is we're going to say f of x is continuous, and there is a change of sign, sign, so this is positive, this is negative, and change of sign. So we're going to say that implies that alpha is less than -1 and greater than -2. Be careful with getting these inequality signs the right way around. You always want the bigger number here and the smaller number here if you're writing your inequality that way. It's quite easy to make a mistake with that. The other thing that it's very easy to do is confuse your x and your y values. So it's often a common mistake seen in exams is here to write that the root is between 6 and -1. Those are the y values. We're interested in the x values. So it's between alpha is between -2 and -1. Now what we want to do is we want to show that alpha is equal to -1.69 to 2 decimal places. Well, to do that, what we're going to do is we're going to look either side of -1.69. So we're going to find f of -1.685, and we're also going to find f of -1.695. What we'll do is we'll draw a little number line in a moment once we've worked these out. What I'm going to do is I'm going to use the calculator. this is going to be visible. Give it a try. So I am going to show you how to do this in hopefully a reasonably efficient way. Just checking to see where we can see it. So I'm going to put in my first value, minus 1.685, and I'm actually just going to press equals, and we now see that we get as a fraction, and there it is as a decimal, minus 1.685 there. I know this is quite difficult to see. Let's turn the light on. Is that better? No, it's not better, is it? Let's turn the light off. It might be better. That's even worse. Right. Hopefully you can see that. Okay. Now what we're going to do is we are going to put in that function. So I'm going to, but using the answer button for the x. So I'm going to say I want answer. So my answer is actually my minus 1.685 at the moment, to the power of 4 plus 2 times answer cubed. Oops, right, wrong. Plus 2 times answer cubed plus 8 times answer plus 15. And that's giving me now the value of f of minus 1.685. So I'm going to write that down. That's 0.13 equals 0.13. And because I've done that with the answer button, what I can do now is I can go back. I can just put in minus 1.695, press equals, and then I can use the up arrow buttons on my calculator. I've got my function in here using the answer button. My answer is now minus 1.695, press equals, and that's giving me the value of f of 1.695. So that's minus 0.045. Minus 0.045. So let's consider what's happening here now. Let's just draw a little part of the x-axis. So here's my minus 1.695. Here's my minus 1.685. Here f of x is positive. Here it's negative. So we've got our root somewhere in between. Now halfway between those is minus 1.69. So if my root is here, it's slightly less than somewhere between 1.690 and 1.685. To 2 decimal places, I would round it to minus 1.69. Same thing here, if it's between minus 1.695 and minus 1.69. To 2 decimal places, I would round it to 1.69. If it's over this side, I'd round it to minus 1.70. If it's over here, I would round it to minus 1.68. So because it's between these two values, I know that to 2 decimal places it is minus 1.69. So we can say therefore alpha is less than minus 1.685, greater than minus 1.695. So alpha equals minus 1.69 to 2 decimal places. Right, that's it for showing you about change of sign. Do remember particularly what you need to write down in the exam questions. Absolutely critical, otherwise you will lose marks when you do these questions. And one final thing is, whenever we have trig functions, we've got to be working in radians. So check your calculator when you have those.